Okay, the objective today is to be able to graph linear equations. Linear equations are equations that have two variables. When we graph an equation with two variables, we are finding solutions to the equation with two variables because any point on the line that is the graph of an equation with two variables, any point on the line is a solution. All right. So a linear equation is an equation whose graph is a line. The points on the line are the solutions of the equation. So if you take a look at this first equation, y is equal to x plus 1, when we want to graph an equation, we can input values for x. So in this case, we make a table, a column for x values, a column for y values, and a column for the ordered pair. The x value is the input value, so we replace x with -1, and then we evaluate. -1 plus 1 is 0, so the output is 0. The input is -1, the output is 0. So your input is your x value, your output's your y value. When you put the x value and y value together, that's your ordered pair. And that ordered pair represents a solution to that equation because 0 is equal to -1 plus 1. Alright, so if we try another value for x, let's say we try 0, we replace x with 0 and we evaluate. 0 plus 1 is 1. So when the input is 0, the output, the y value, is 1. So the ordered pair is 0, 1. 0, 1 represents a solution to that equation. And when we put those ordered pairs on the coordinate plane, we create a graph of a straight line. So let's try an example or two. First example here is the equation y is equal to -2x plus 1. So we want to substitute or replace x with some values to create output values. So let's try -1. Let's try 0, and let's try +1. I always like to do negative values and positive values when I create a table of values to graph an equation, because you want to see what the graph looks like on the left side of 0, and you want to see what the graph looks like on the right side of 0. So when we replace x with -1, it looks like this, right? -2 times -1 plus 1. -2 times -1 is +2. +2 plus 1 is +3. So to create the ordered pair, the input value was -1, the output value is +3, so the -1, 3 is the ordered pair. And that ordered pair represents a solution to that equation. The solution is a value for x and a value for y that's going to make that equation true. Alright. If we replace x with 0, this becomes -2 times 0 plus 1. -2 times 0 is 0. 0 plus 1 is 1. So when the input 0, the output is +1. Your ordered pair is 0, 1. 0, 1 is another solution of that equation with two variables. More often than not, or almost always, right, we are going to have an infinite number of solutions to an equation with two variables. Let's replace x with 1 here. So this is going to be -2 times 1. -2 times +1 is -2. -2 plus 1 is going to be -1. Right? And so our ordered pair is going to be 1 and -1. And when we graph these ordered pairs, -1, 3 is this point here. 0, 1 is this point here. Then we have 1, -1 is this point here. Right? Each one of those ordered pairs represent a solution to that equation. Okay. When we have a horizontal line, right, the graph of a horizontal line looks like this. Right? The equation y is equal to -3. So where is y equal to -3? Well, I look at my y-axis and I locate -3 on the y-axis and I put a point, and then I draw a horizontal line through that point, and that's the graph of y is equal to -3. Horizontal lines are going to begin with a y value, and on the right side will be an intercept, -3 on that y-axis. If I want to graph x is equal to 2, right, the graph of x equal to 2 is going to be a vertical line. Right, I would start on the x-axis where x equals 2. Right, here's where x is equal to 2 on the x-axis. You draw that vertical line through that point. Right, and one thing to note is every point on that line, the x value is +2, right? So if I take this point here, right, that point is 2, 2. Notice the x value is 2. If I take this point all the way down here, right, that's 2, -3. Right, notice the x value is 2. So on the graph of x is equal to 2, every point on that line, the x value is going to be 2. And the same is true for the previous equation, where we graphed y is equal to -3. Every point on this line, the y value is going to be equal to -3. Right? So if I locate this point here, that's 3, -3. Right? Notice the y value is -3. Or if I locate this point here, right, that's -3, -3. Right? Notice once again the y value is -3. Right? So if I have a horizontal line, the equation of that horizontal line is going to begin with y equals. Every point on that line is going to have a y value the same as the constant that's on the right side of that equation. Alright, let's go ahead and graph some of these equations here. Alright, we're going to use one coordinate plane to do that. So I'm just going to draw one vertical line. Let's extend that a bit. Alright, draw that all the way down. I want to extend that. Alright. And I need a horizontal line. Alright, let's draw a horizontal line. Okay. Let's start with y is equal to 3 times x. So if y is equal to 3 times x, I'll make my table over here. We have a column for x. We have a column for the expression here, 3 times x. We have a column for our y values. And then we should make a column for our ordered pair. Okay, that would be x comma y. Okay. Let's try -1, 0, and 1. 3 times -1 is, let's see, right, that's -3. Then we have 3 times 0. Then we have 3 times 1. Right, we're replacing x with each of these input values. The output, 3 times 0 is 0. Here, 3 times 1 is 3. So to create the ordered pair, I take the x value, I take the y value, put them together in parentheses. -1, -3 would be the ordered pair. When the input's 0, the output is 0, so 0, 0 will be the ordered pair. When the input's 1, the output's 3, so 1, 3 is going to be the ordered pair. All right, let's go ahead and graph that. So we have -1 and -3. I'll do that in blue. I might as well keep it matching. -1, -3 is going to be this point here. Then we have 0, 0. Then we have 1, 3. That's going to be this point here. All right, we get a collection of points in a straight path. All right, I want to graph that line. All right, I'm going to make that line blue. All right, let's extend that here. All right, let's make that line blue. Properties, and well, line style, we'll make it blue. Blue. There we go. Now I always like to put arrows at the end of my line to show that the line goes on forever in both directions. So you put an arrow at one end, put an arrow at the other end, just to show that the solution is going forever in both directions. And remember that each one of these points that we graphed represents a solution of that equation, y is equal to 3 times x. Right, let's try this one, and we'll make the table in red. So we have column for x, column for -1/2 x plus 2, and a column for y, then a column for the ordered pair x comma y. Alright. Now when we have an equation where the coefficient of the variable is a fraction, right? We want to be a little bit more choosy with our input values, right? And what do I mean? Well, in order to get integer values as our outputs, I want to choose input values that are divisible by 2, and this way we're going to get integer values for our output. So I'm going to use -2, 0, and +2. Right, and this way I know I'm going to get integer values for the output. -1/2 times -2 plus 2, and then we have -1/2 times 0 plus 2. Then we have -1/2 times 2 plus 2. We evaluate. -1/2 times -2, that's +1 plus 2 is 3. So when the input is -2, the output is +3. So my ordered pair solution is 2, 3. When the input is 0, let's see, -1/2 times 0 is 0. 0 plus 2 is 2. So 0, 2 is the ordered pair solution. All right, and this last one, -1/2 times 2 is -1. -1 plus 2 is +1. So my ordered pair solution is 2, 1. Right, if I want to graph those ordered pairs, we start at 2, 3, and then we have 0, 2, and then we have, let's see, made a mistake. Let's correct that. Right, that was, this first ordered pair is -2, 3. Now, how did I know it was a mistake? Well, if I go back, let's go back. How did I know that I did something wrong? Because this point here, 2, 1, 2, 1 would have been here. Now I'm supposed to be graphing a straight line, but obviously, right, this looks like a V. That's not a straight line. So I know I did something wrong. So you want to go back and look at your work and check your ordered pairs, and I see that I did not make this 2 a negative, right, which it should be. So I'm just going to go ahead and correct that and make this 2 a -2, and now the ordered pair is going to be correct, because we have -2, 3, which is this point here, 0, 2, and then 2, 1. Right? You should get a collection of points in a straight path. If you don't get a collection of points in a straight path, then you know that you did something wrong. Right? You want to go back and check your work. All right? So I'm just going to extend this line a bit. All right, I'm going to change the color, make that red. All right, properties, and let's make that red. And I always want to put the arrows at the end of the line. Arrow here, and that would be the graph of y equals -1/2 x plus 2. Right? We should label our lines. I like to do that. So let me go back and label this blue one here. That is y is equal to 3x. So that's y is equal to 3x. All right. Let's try this next one. Well, x is equal to -4. That's an easy one, right? Right. So where do I find x is equal to -4? Well, x is equal to -4 right here. Right here's my x-axis. On the left side of 0, x is going to be negative. So right here is where x is -4. Right? Every point on that line, the x value is going to be -4. Right? So I draw my line, right, in both directions, put an arrow, and there's the graph of x is equal to -4. Right? That's going to be a vertical line. Right? And this next one, what color did I use? Green. Y is equal to -1.5. Well, where on my y-axis is y is equal to -1.5? Well, that's going to be right here. So I want to draw a horizontal line through that point, right, where y equals -1.5. Let's try a few more examples. Now, in the lesson, I wanted to give you guys some equations with some fraction coefficients, because they're always a little tougher to graph. So I wanted you guys to get into the habit of, when you have fraction coefficients, make sure that you use inputs for x that are going to be divisible by the denominator. Right? So let's take a look at this first one. I'm just going to make a column of x and y, right? Because we should be able to do this in our head. So here's a column for x and y. Well, I see that this is divisible by 2. So I want to use values that are going to be divisible by 2, but I also want them to fit on this, this graph here. So let's start with negative 4. If negative 4 is my input, well, what's negative 5 halves times 4? Well, negative 5 times negative 4 is what? Negative 5 times negative 4 is positive 20. Positive 20 divided by 2 is going to be positive 10. Right? But I'm not going to be able to fit that on my graph. So let me try something, right, a little smaller. If we do, instead of negative 4, let's try negative 2. Negative 5 times negative 2 is positive 10. Positive 10 divided by 2, that's going to be 5. So that's going to fit on my graph. Right? We know 0, right? If the input's 0, negative 5 halves times 0, the output's going to be 0. So let's do a negative 2 or a positive 2. So if we do positive 2 as my input, right, positive 2, negative 5 halves times 2, that's negative 5 times positive 2, that's negative 10. Negative 10 divided by 2, it's going to be negative 5. So my ordered pairs that are going to be able to fit on my graph are negative 2 comma 5. Here's negative 2 comma 5 is going to be here. Then we have 0 comma 0. And then I have positive 2 comma negative 5. Right? I see the collection of points in a straight path, so I feel pretty confident that we graphed that correctly. Right, let's put arrows at both ends of our line to show that the solutions go on forever in both directions. Right, let's try this one here. We'll do this in red. Right, we'll do, oops, should be red, column for x and a column for y. Right, now the denominator is a 5 here. So if the denominator is a 5, right, we want inputs that are going to hopefully fit on our graph. So let's try negative 5, see if that's going to work. Negative 2 times negative 5, negative times negative is positive, so that's positive 10 divided by 2, or I'm sorry, positive 10 divided by 5, that's positive 2, 2 take away 4, output should be negative 2. And I'm going to know if we did the math correctly, if the points are in a straight path or not. If they're not in a straight path, we know we screwed something up. So let's try 0 here, right? Negative 2 fifths times 0 is 0. 0 take away 4 is negative 4. All right, and then let's try positive 5. All right, negative 2 fifths times 5. Negative 2 times positive 5, that's negative 10. Divided by 5 is negative 2. Negative 2 minus 4 is going to be negative 6, right? Looks like those ordered pairs are going to fit. So we start with negative 5, comma negative 2 is going to be here. Then we have 0, and negative 4 is going to be here. And then we have 5 and negative 6. That's going to be here. And it looks like, right, that's a collection of points in a straight path. That looks like that's going to work. So I want to, right, draw that line. I want to extend it. And then I want to put arrows at the ends. Right, let's put arrows at the ends. And the arrows represent the fact that they will go on forever. Right, let's make that red. And arrow at the end, arrow at the end. And that's the graph for y is equal to negative 2 fifths x minus 4. All right, let's try this next one here. Once again, the denominator is a 5, so I want to use values that are divisible by 5. So let's do x is our input, y is our output. So let's do what? Negative 5, 0, and positive 5. Let's try that. Negative 1/5 times 5, that's going to be positive 1. Positive 1, take away 2, it's negative 1 for the output. If we replace x with 0, negative 1/5 times 0 is 0. 0 take away 2 is negative 2. Negative 1/5 times 5, that's going to be negative 1. Negative 1 minus 2 is going to be negative 3. So my first order pair is going to be negative 5, comma negative 1. That's going to be here. 0, negative 2 is going to be here. 5 and negative 3, that's going to be here. Looks like my points fall in a straight path. So that should be correct. Alright, let's put arrows at the end of that. Arrow here to show that those solutions go on forever. Alright, and this last one here, we have a denominator of 3, so I want to use input values that are going to be divisible by 3, and I do that to get integer values for my outputs. So I'm going to try -3, 0, and +3. -1 times -3 is, -1/3 times -3, that's going to be +1, plus 4 is 5. -1/3 times 0 is 0, 0 plus 4 is 4. -1/3 times 3 is -1, -1 plus 4 is 3. All of those ordered pairs will fit on this coordinate plane. So we have -3, comma 5 is going to be up here, 0, comma 4 is here, 3, comma 3 is here. Right? I get a nice collection of points in a straight path. Right? We connect those points, and that's the graph for y is equal to -1/3 x plus 4. All right? Now these next couple of examples are a little bit different. Notice that the equations are not in the form where y is equal or y is all by itself. So we have to first solve each one of these equations for y. So in this first equation, y plus 2x is equal to 3. We'd have to subtract 2x from both sides of that equation. All right? And when we subtract 2x here, all right, subtract 2x here, that's going to be 0 on the left side of the equation. So now we're left with y is equal. But then I want to use the commutative property and rewrite that as -2x plus 3. Right? And then make my order pairs x and y. And let's do -2. Or let's do -1, 0, and 1. -2 times -1 is -2. -2 plus 3 is 1. -2 times 0 is 0. 0 plus 3 is 3. -2 times +1 is, I did this wrong, right? But I would have found that out when I graphed it. It wouldn't have been a straight line. -2 times -1 is +2. Positive 2 plus 3 should be 5. Right? And then this would be 1. So I want to graph those ordered pairs. So we have -1 and 5. That's going to be up here. 0 and 3 is going to be here. 1 and 1 is going to be here. And once again, your points have to fall in a straight line, right? And then you know that your graph is correct, or you're pretty confident that your graph is correct. And if your points don't fall in a straight line, you know you did something wrong, right? And let's put arrows at each end. Show that that line goes on forever in both directions. And remember, every point on the line is a solution to the equation with two variables. Right, this next one, we have 2 times y minus 3 times x is equal to 1. We want to solve that equation for y. To do that, we want to add 3x to both sides of the equation. On the left side, they cancel. You're left with 2 times y is equal to 3x plus 1. We're just going to use the commutative property there. Now we have to divide by 2 on both sides of the equation. When we divide by 2, they cancel on the left side. We're left with y is equal to 3/2 x plus 1/2. Alright, now, I want to use, let's see, I want to use some values to hopefully get integer values here. So x comma y. Right, let's try, if we do, yeah, that'll work. Right, if I use -1, 3/2 times -1, that's -1.5. -1.5 plus 1/2, that's going to be -1. Right? 3/2 times 0 is 0. 0 plus 1/2 is going to be 1/2. Alright. It's going to be 1/2. So 0 comma 1/2. And if we try +1, 3/2 times 1 is 1.5. 1.5 plus 1/2, that's going to be 2. So we have 1 comma 2. So let's graph these ordered pairs. We have -1, and -1 is going to be here. 0 and 1/2 is going to be here, and then 1 and 2 is going to be up here. And once again, we do get points in a straight line. Right? Should use a ruler to do that, but that's as straight as I can do it freehand. Right? That's going to be the graph of 2y minus 3x is equal to 1. Alright, now this think this is the last page here, right? Yeah, the last page here. The equation y is equal to 2 times the number x plus 4 represents the cost in dollars of renting a movie after x days of late charges. First, we want to graph the equation. All right, so we're going to make a column for x and a column for y. We can do that real quick. We only have 4 here, so if I use, let's use negative 2. If x is negative 2, 2 times negative 2 is negative 4. Negative 4 plus 4, that's going to be 0. All right, let's try, let's do negative 1. 2 times negative 1 is negative 2. Negative 2 plus 4 is going to be positive 2. All right, let's try 0. 2 times 0 is 0. 0 plus 4 is 4. All right, and I think that's all we have that's going to fit, but that'll be enough. Negative 2 comma 0 is going to be here. Negative 1 and 2 is going to be here. 0 comma 4 is going to be here. All right, so this would be the graph of the line. All right, let's extend it a bit. Let's put arrows at both ends, show that the line goes on forever, as do the solutions. Part B says use the graph to determine the cost after 3 days of late charges. Wow. After 3 days. Well, after 3 days, that's going to be, let's see, X represents the number of days of late charges. So 3 days, I'm not going to be able to use my graph to do that because that's going to be all the way up here. So what's another way to do that? Well, simply replace X with 3. So we have Y is equal to 2 times 3 plus 4. 2 times 3 is 6 plus 4 is 10. So Y is going to be equal to 10. All right, now, normally we would try to use the graph there, but I have very limited graph paper, and Y is equal to 10 is going to be all the way up there. All right, so how much does it cost? Right, well, the cost is going to be $10. All right, and I think, all right, we're going to stop the lesson there, so hopefully, some of this will be helpful, and good luck.